Well, in this video, what I'm going to do is I'm going to go over the stomach. The stomach looks like this. It's kind of like a J-shaped organ. Okay. And the stomach is going to receive the food from the esophagus, okay, which comes from your mouth.
Process of deglutition or swallowing. The first phase, the buccal phase, begins with the compression of the bolus against the hard palate. The second phase, the pharyngeal phase, begins as the bolus comes in contact with the palatal arches and the posterior pharyngeal wall. The third phase, the esophageal phase, begins as the contraction of pharyngeal muscles forces the bolus through the entrance to the esophagus. In the final part of deglutition, the approach of the bolus triggers the opening of the lower esophageal sphincter. The bolus then continues into the stomach.
And then once that food reaches the stomach, it's going to take about 3 to 4 hours to process that food. The stomach is a highly acidic environment, anywhere from a pH, I think, of 1.5 to 1 to 2 pH. Okay, very acidic.
There are 3 important functions of hydrochloric acid in the stomach. First, hydrochloric acid kills most of the microorganisms ingested with the food. Second, hydrochloric acid denatures proteins and inactivates most of the enzymes in food. And the final function of hydrochloric acid in the stomach is that it helps break down plant cell walls and the connective tissues in meat.
Okay, so let's name some components of the stomach. Okay, here you have the cardiac region. This is the fundus. Let's bring a little bit closer here. Cardiac region, the fundus, this like bump-looking part here. This is the body. And over here we have the pyloric region.
There are 4 parts that make up the pyloric part or region. The first part is called the pyloric antrum. Then there's the pyloric canal, followed by pylorus, and finally there's the pyloric orifice.
Food comes in here through the cardiac sphincter of the cardia. Okay, the sphincter will relax and the food will come into the stomach. And then the food will exit here via the pyloric sphincter. Pyloric sphincter is inside there, and that will help close the pyloric region, or the pyloric part. So when both of these, the cardiac and the pyloric sphincters are closed, they're able to keep the food in here for 3 to 4 hours, and the acidic kind, or the acid is converting that food into a substance called chyme. And the chyme is kind of like the consistency of applesauce. Okay, so let's keep on going over some other parts here. Here we have the lesser curvature, and this is the greater curvature out here. Greater curvature, lesser curvature. The lesser curvature will have the lesser omentum, which will go to the liver, and the greater curvature is a fatty apron. Some people have it more than others, but there's a lot of fat that gets stored in that apron, giving you that big old belly if you are not careful. Okay? So greater omentum, lesser omentum on the top. Also, you can see here the layers of the stomach. Not all of them, but at least the Serosa, Muscularis, Externa. So the Serosa will be this outer layer here, also referred to as the, or also known as the Visceral peritoneum. Okay, and in here we can be able to see the 3 layers of the Muscularis externa. Okay, let's see from this side. See, on this side you can see the fibers, the myofibril, well, actually smooth muscles, so we'll not say myofibrils, but the fibers are running parallel to the stomach. That's part of the longitudinal layer. Then this layer, you see the fibers here, they run perpendicular to the longitudinal, so that's a circular layer. And inside here in this box, you're going to be able to see the oblique layer. So those 3 layers, the oblique, the circular, and the longitudinal, make up the Muscularis externa. And I think I can venture to say that these yellow ones here, that's part of the RBAC, or my anterior plexus, which helps stimulate that Muscularis externa to contract. Very nice. I think I've seen that there for the I've seen that there before, but now I can put it in perspective better. Okay, so let's see if what we can look at inside. Here you see this hamburger-shaped structures. That's part of the mucosa. That's called the rugae. Okay, rugae. Think of reggae. Rugae. Let's memorize that. And then here you have the layers. Here we have the Muscularis externa. This is the submucosa. And this is the mucosa. Okay? So Muscularis externa, submucosa, and then mucosa. Okay? Alright, so what else can we do here? Let's look on this half here. You can see these two structures inside here. Alright. Here you have the gastric gland, and this is the gastric pit. Okay, gastric gland and gastric pit.
There are two cells that reside in the gastric gland. First, there's the parietal cells. The parietal cells secrete HCl and intrinsic factor. The chief cells, in the presence of hydrochloric acid, convert pepsinogen to pepsin.
And the gastric pit, which is where the hydrochloric acid will surface to and eventually go out to the rugae. So let's look at this other model here, the histology of the stomach. Okay, this model. Okay, so this is going to be the layers of the stomach. Okay, so we can go into it here. Outside here we have the serosa. Here we have the Muscularis externa. The Muscularis externa is made up of 3 layers. We have the longitudinal layer, the circular layer, and the oblique layer of the Muscularis externa, stimulated by the Auerbach's or myenteric plexus. Okay, then we have here the
submucosa.
Then we have the Muscularis mucosa. And then we have the mucosa. Okay, so there's our mucosa. And then here you have the gastric gland, and then the gastric pit. And then there's one more chemical structure that you should know, which is called gastrin. Gastrin is a hormone that helps break down proteins in adults. And in the babies, they don't produce gastrin. What they do is produce renin, R-E-N-N-I-N, 2 N's, and that renin will help break down the milk in the babies. All right, so that's pretty much it. That's all I can really think of. Just one thing I want to tell you is that the layers that you'll find in the gastrointestinal tract are pretty much similar throughout. You have a serosa, a Muscularis externa, a submucosa, a Muscularis mucosa, and a mucosa. Now the only difference is that the stomach is going to have 3 layers in the Muscularis externa, while the small intestine and large intestine is going to have only 2 layers, which is longitudinal and circular, stomach having that extra oblique layer in addition to circular and longitudinal. And instead of having rugae in the stomach, which looks like kind of like a hamburger meat, the intestines will have a structure called, the mucosa will have villi. So the mucosa in the stomach will be rugae, the mucosa in the small intestines will be villi. All right, so that's pretty much it for the stomach. The next video I'll be doing the small intestine, so stay tuned for that, and eventually after that the large intestine. So hope you like this video, and hopefully you can subscribe so you can get any notifications of the any future videos. And that's pretty much it. So okay, I'll see you in the next video. Take care. Bye.